Yesterday, as you know, that we had done with the preparation of the insoluble salt. Insoluble salt, I have told you, it could be prepared by one method which is called as the precipitation method. And in precipitation method, I've told you that the two soluble salts, they are being mixed together. One of the insoluble and one of the soluble salt should be formed as a result. Okay. So I have given you a number of salts to practice from your home. So let's take the example of the magnesium carbonate. I have given you the work tomorrow, magnesium carbonate. So first of all, we have to think about the solubility of the magnesium carbonate. मैंने आपको solubility का एक chart बताया था. That most carbonates, they are insoluble except for KNN, potassium, sodium, and ammonium. So it means magnesium carbonate, my dear students, it's an insoluble salt. Okay, it is the first thing, and it could be prepared by the method precipitation. The second thing I've told you to make its equation. How you can make the equation? You have to take a salt in which magnesium is present, and that should be soluble. I've told you take the nitrate of the first thing, so magnesium nitrate. How could you make the formula of magnesium nitrate? Magnesium has got the valency +2, nitrate has got the valency -1. So the formula of magnesium nitrate, my dear, it would be Mg NO3 whole twice. This is aqueous because it is soluble. Okay. Now take the second salt in which CO3 carbonate is present, and that is soluble. I have told you that most carbonates are insoluble except for KNN, potassium, sodium, and ammonium. So take the sodium carbonate, sodium Na+1, and CO3, that is -2. So the formula of sodium carbonate, that would be Na2CO3. So whenever you want to make the formula, the 2 will come up here and 1 will come up here, plus and minus, they would be cancelled. Okay, so just like that you can make the formula. Okay, so this is also aqueous. So when you mix them together, so what would happen? The positive of one thing will join with the negative of the other thing, like that. So Mg is joined, Mg, this is the positive of one thing, CO3, that is the negative of other thing. They would join together. So +2 -2, they would be cancelled. So as a result, you are going to get Mg CO3. This is the insoluble salt. So you should write solid at the base of it. Okay, and then sodium and nitrate, they would join together to form NaNO3. So this is aqueous. Okay, guys. So this is the equation. So second marks, 1 mark for this one and 1 mark for this one. And make the Ionic equation. I have told you the simplest method of making the Ionic equation. Find a thing which is solid, liquid, or gas in the whole equation. So this is aqueous, this is aqueous, this is solid only, this is also aqueous. So write down this solid thing, MgCO3, this is solid, and write its ions up here. Mg, that is +2, okay, and CO3, that is -2. So this is aqueous, and this one is solid. So this is the Ionic equation. Now how could you write its description? I have told you yesterday, mix aqueous magnesium nitrate in aqueous sodium carbonate till a precipitate of magnesium carbonate is formed. Filter the precipitate, wash the precipitate with distilled water so that the soluble impurities will wash away and dry in the hot oven. So this is the description I have told you yesterday. You got it, guys?
Sir, I have a question.
Yes, my dear.
Sir, आपने ऊपर लिखा है Na2CO3. तो सर हम Na की जगह क्या पोटेशियम यूज कर सकते थे?
बिल्कुल कर सकते हैं बेटा, कोई भी सोलुबल सॉल्ट ले सकते हैं जिसमें कार्बोनेट आ रहा हो. तो KNN, पोटेशियम, सोडियम, अमोनियम, कोई भी सोलुबल ले सकते हो. कुछ जरूरी नहीं है मैंने सोडियम ले लिया, आप पोटेशियम ले लो, अमोनियम कार्बोनेट ले लो, कुछ भी ले लो. यू गॉट इट? ये मैंने थोड़ी सी आप लोगों को इसकी करवाई है. Okay, the next salt, उसकी भी preparation discuss कर लेते हैं. That is the lead chloride, PbCl2. ओके, सो PbCl2 जो है, इसकी solubility सबसे पहले देखते हैं. मोस्ट क्लोराइड्स या मोस्ट हेलाइड्स आर soluble एक्सेप्ट फॉर स्लो लर्नर मैन, सिल्वर, लेड, मर्करी. तो सिल्वर, लेड और मर्करी अगर हेलोजेंस के साथ लगा होगा तो दैट वुड बी द इनसॉल्युबल सॉल्ट. तो लेड लगा हुआ है, सो इट मींस इट्स एन इनसॉल्युबल सॉल्ट एंड इट कुड बी प्रिपेयर्ड बाय अ मेथड प्रेसिपिटेशन. ओके, so how could you make the equation of it? lead का कोई soluble salt ले लो, तो lead nitrate ले लो, Pb plus 2 NO3 minus 1, so lead nitrate, so Pb NO3 whole twice, this is aqueous. Okay, and then chloride की कोई soluble चीज ले लो, potassium chloride ले लो, K plus 1 and Cl minus 1. yes बेटा,
मैं कह रही हूँ HCl ले लें.
बिल्कुल HCl ले लेते हैं जी, ये लें HCl ले लेते हैं इस दफा, ये लें जी. H plus 1 होता है, Cl minus 1, so HCl we have taken, aqueous. So when we mix them together, so what would happen? The positive of this thing will join with the negative of this thing, so it would become lead chloride, PbCl2, solid. Okay, and H would join with the negative of this thing, so it would become HNO3. So this one is again aqueous. So if you want to make the ionic equation, so the thing which is solid, liquid or gas, this is solid. So write this thing, PbCl2 solid, and now write its ions up here, Pb plus 2 aqueous and 2Cl negative, that is also aqueous. So this is the ionic equation. Now write down its description. Mix aqueous lead nitrate in hydrochloric acid till a precipitate of lead chloride is formed. Filter the precipitate, wash the precipitate with distilled water so that the soluble impurities will wash away, dry in the hot oven. You got it? So the same description I have told you yesterday. Is it clear, my dear?
Yes sir.
Yes,
Yes,
sir.
sir.
सर ये जो Mg CO3 वाला था, इसमें मैंने CO3 के साथ Mg लिया था.
बिल्कुल यार, you can take any soluble salt, my dear. CO3 के साथ क्या लिया था?
CO3 के साथ नहीं, I think सर मुझे confusion हो गया, sorry.
अच्छा. Okay beta, so this was the yesterday's thing we had discussed. So today we are going to discuss with the preparation of the soluble salt. Okay, so today's topic is very important. I want everybody to focus on it. So today we are going to start with the preparation of soluble salts. Okay, I have told you, my dear, the soluble salts, they could be prepared by mixing the acid with 4 things. Okay, so acid, it could react with the metal. Acid could react with the metal oxide. Okay, acid could react with the metal hydroxide, and acid could react with the metal carbonate. So these are the 4 reactions of acids. So when they react together, as a result, salt is formed, and the salt form, that is always the soluble salt. Keep remember that. Okay, so you will get the soluble salt when these things react together. So if you want to prepare the soluble salt, there are the 2 methods, my dear. The first method, that is called as the titration method. Okay, and the second method, that is called as the crystallization method. So when you people are going to use these methods, okay, now listen it very carefully. Okay, my dear, the titration method could be used only when you got a salt in which the group 1 metal is present, or ammonium NH4 plus 1 that is present. If these two things are present in a salt, and the salt is soluble, then you can use the titration method. And if you did not get the group 1 metal in the salt or ammonium inside it, you did not get these things, you have not these things, you have got any other metal like group 2 metal, transition metal, group 3 metal, any other metal, okay, except for group 1 or ammonium, then you have to use the crystallization method if the salt is soluble. Let's take an example, my dear. Let's suppose I'm going to write down the two uh, salts up here. The first one is sodium sulfate, Na2SO4, and the second one, that is copper sulfate, CuSO4. Okay, now in the paper the periodic table is given. Okay, now first we have to know the solubility of these two salts. Okay, sodium sulfate and copper sulfate. I have told you the solubility rules. Now I'm telling you about the sulfates, that most sulfates are soluble except for low blood cholesterol, lead, barium, calcium. Low for lead, uh, blood for barium, and cholesterol for calcium. So low blood cholesterol, lead, barium, and calcium sulfate, they are only insoluble. Otherwise, all the sulfates are soluble. So it means both of these salts, they are soluble salts. So this is our first step. This is the soluble salt. Now the soluble salt, my dear, they could be prepared by the titration method or the crystallization method. So which method we should use now? Now we have to see the metal. The first thing present, that is always the metal. Sodium and copper, these are the metals. The first thing, that is always metal. The second thing, that is non-metal. So we always have to look the first thing. Now take the sodium. Have a look in the periodic table that in which group it is present. If you open the periodic table, my dear students,
One.
it is always present in the group 1, sodium. So it means the group 1 thing, if it is present in the salt, or ammonium that is present in the salt, so you use the titration method. So it means sodium sulfate could be prepared by the titration method, whereas the copper sulfate, it could be prepared. Copper is not the member of the group 1, it is in the transition metal, so it could be prepared by the crystallization method. So crystallization method, we will discuss it later on. Firstly, we are going to discuss about the titration method. So it means the first thing, sodium sulfate contains group 1 metal inside it. Sodium is a group 1 metal. So it means it could be prepared by a titration method. Okay, so you should write sodium sulfate could be prepared by titration method. So you will get for 1 mark for it. You got it, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, my dear students, the next thing that is very important. Okay, the next thing, you always have to take the first thing, hydroxide. The first thing is actually metal. So you can take metal hydroxide. Okay, or you can take metal carbonate. Okay, so both of these things, metal hydroxide or metal carbonate, these two things. Okay, and the second thing, and these two things, keep remember that they are soluble in water. They are soluble in water. Okay, and the second thing, sulfate, its acid should be taken. So you have to think about an acid in which SO4 is present. So H2SO4. So SO4 is present in H2SO4. So you can take H2SO4 up here. If Cl is written up here, you can take HCl. If NO3 is written up here, you can take HNO3. If PO4 is written up here, you can take H3PO4. So I have given you some acids at the start of the salt chapter. So you can see those salts. You can write down those acids up here. Okay. Now I suggest you, whenever you are going to take, you can take any of the thing up from here, metal hydroxide or metal carbonate. You can take any one of these two things. Okay, so let's suppose I'm going to take hydroxide. Okay, so first of all, my dear, I'm going to make the equation. So what should I do? So sodium Na plus 1, the hydroxide, that is OH minus 1. So what the formula I get? NaOH. So I'm going to write up here NaOH. So it is soluble. I should write aqueous up here. Okay. So the second thing is acid. So SO4, the acid which contain SO4 inside it, that is H2SO4. So write acid up here. And I've told you that the acid shows its worth when it is dissolved in water. So write down H2SO4, it is also aqueous. Okay. Now make the ions of the acid as well, H positive and SO4 minus 2. So whenever, my dear students, you want to make the equation, what should we do? Join the positive of one thing to the negative of other things. So it would become Na2SO4. So Na2SO4. So this is the soluble salt, write aqueous up here. H positive and OH negative, it would join together to form the water. So you should write water up here. This is the liquid. Water is a liquid. Now, if you want to make the ionic equation of it, so I have told you a simplest rule, the Desi rule. What is the Desi rule? Have a look in the equation that anything which is solid, liquid or gas, anybody could tell me?
H2O.
H2O, that is a liquid. So just write H2O up here. H2O liquid, and then write its ions up here, H positive and OH negative, and write aqueous and aqueous up here. So this is the ionic equation. If you want to make the ionic equation technically, my dear, so how could you make it? The things which are aqueous, just make the ions of them. Na plus 1, OH, that is minus 1, H is plus 1, SO4, that is minus 2, Na plus 1, SO4, that is minus 2. Now cut the same ions which are present on both sides. Sulfate would be cut with the sulfate. Na positive, it would be cut with the Na positive. So you will get OH negative, H positive, and water. So this is the water. So you will get the same ionic equation. Is it clear, my dear?
सर ये टाइट्रेशन मेथड लिखने के बाद से जरा प्लीज एक्सप्लेन कर दें, मेरा नेट का मसला आ रहा था मुझे नहीं
बेटा
समझ
टाइट्रेशन मेथड, आई हैव टोल्ड यू, टाइट्रेशन मेथड हम तब यूज करते हैं जब आपके पास ग्रुप 1 की मेटल हो या अमोनियम हो। आपको ये दो चीजें बताई हैं, ठीक है। हमने क्या करना होता है कि आपने सोडियम है, ये ग्रुप 1 का है, तो इसका मतलब है टाइट्रेशन मेथड यूज करेंगे। पहली जो चीज होती है मेटल, उसका या तो हाइड्रोक्साइड ले लो या कार्बोनेट ले लो, और ये दोनों चीजें पानी में सॉल्युबल हैं। दूसरी चीज का एसिड ले लो, तो यहाँ पे हमने ले लिया सोडियम का हाइड्रोक्साइड ले लिया, NaOH, SO4 का एसिड ले लिया, H2SO4, इनको मिक्स किया तो Na2SO4 और वाटर बन गया, और इसकी आयनिक इक्वेशन बना दी है बस। यू गॉट इट?
Yes,
Okay,
sir.
dear, can you please take the screenshot of it? Guys, can you take the screenshot of it? Taken?
Done, sir.
Done.
Yes, sir.
Okay. Now what you
Done.
have to do now? अब जो चीज समझने वाली है वो बहुत important है. The thing which I'm going to describe you is very important now. Now, how the titration method that is being carried out, just listen it very carefully. After that, I will write everything for you. Don't you worry about it. First of all, just listen that how you have to do the process of the titration. Okay. First of all, my dear students, you have to take a flask. This is a flask. And this flask, that is called as the titration flask. This is called as the titration flask. So what should you do, my dear? in this titration flask, what should you do? By using a pipette. Here is a instrument which is called as the pipette. So this is the pipette. I'm going to draw its diagram. So this is the pipette. This pipette is open on its both ends, and it has got just one mark on it. Just one mark is written. Okay, and it can measure only 25 cm cube, not less than that, not more than that. And this instrument that is called as the pipette. This is the pipette. Okay, so it has got its both ends open. So what should you do if you want to fill something inside the pipette? This end should be dipped in the solution which should be filled inside it, and this end should be in your mouth. This is the simplest desi method I'm telling you. This end should be in your mouth. What you do, you just suck it, suck the liquid. So liquid will suck inside it, and when it will come at this point, you just stop sucking and just put a thumb up here, your your hand's thumb. Okay, so the liquid will not stop, the liquid will not go down until your thumb is present up here. Now transfer this one into the titration flask and put and open up your thumb, so all the liquids would be transferred up here. So what should you do? You should transfer 25 cm cube of sodium hydroxide in it. So this is the simplest method I've told you, by using your mouth. But the problem is that if the liquid that is harmful, and if you do the sucking process and the liquid by chance enter in your mouth, so it will cause damages. So now what should you do? You should use some safety measures for it. We have to use a bulb which is called as the safety bulb for it. Safety bulb. Or this one is also called as the pipette filler. Okay, so this pipette filler, my dear, this pipette filler is used to fill the liquid inside it. Okay, up till this point. So this pipette filler has got the 3 buttons on it, like that. I'm going to make it up here. Okay, so here are the 3 buttons. Okay, on one button the word A is written, on other S is written, on other E is written. So first of all, my dear, if you want to fill anything within the pipette, what should you do? You should press the A button, and this safety bulb is just like a rubber ball. Just press it. So what would happen? All the air will go out from it, and it will be without air position. Okay, it will remain in that position. Now leave the A button. So this ball that would be without air. Okay, now what should you do, my dear? You just transfer this pipette in the liquid. Okay, let's suppose I'm going to transfer it in a beaker which is having the liquid inside it. So this is the liquid present up here. I want to fill the liquid in the pipette. Now what I'm going to do, I'm going to press the second button, that is S for suck. So what would happen? The liquid will start sucking within the pipette, and when it will reach up till that point, you should stop pushing the S button. And now take this pipette into the titration flask and push the E button. E for empty. The word E, that is empty. The word S, that is for suck. And word A, that is for air. Okay, so when you press the E button, so all the liquid that would be transferred into the titration flask. So my dear students, by means of pipette, what should you do? You should transfer 25 cm cube of sodium hydroxide, whatever the metal hydroxide you got. I've just mentioned up here sodium hydroxide. If you have got some other hydroxide, you can write the name of that hydroxide. Okay, now the second thing, my dear, you should take another instrument which is called as the burette. So burette is a long tube. Okay, it become thinner at its one end, and it has got a tap at its end. this is a lock, okay, and it has got many marks on it, okay. So this instrument that is called as the burette. In that burette, my dear, it is going to start from 0. 0 is present at the top and is going to end at 50. So 50 is present at the base, okay. So in that burette, what should you do? You should fill the acid. So the acid we have got up here, that is H2SO4, sulfuric acid, okay. So fill the sulfuric acid inside the burette, okay. Now the third point, the titration flask, this contains 25 cm cube of sodium hydroxide. The burette, it contains the sulfuric acid in it up till the point of 0. Now the third thing, you have to transfer the indicator inside it. Indicator, I have told you, a solution which shows different color in the acid and different color in the base, okay. So what should you do? You should transfer some indicator inside the sodium hydroxide solution, okay. So just transfer it. Okay, now open the tap of the burette. When you open the tap of the burette, what would happen? The drops will coming out inside it, and you should start stirring this sodium hydroxide solution. You are going to shake this solution of sodium hydroxide with your hands. So what would happen? A time will come when the indicator that is going to change its color. So as soon as the indicator change its color, what should you do? You should off the lock. Just this tap should be off, and just see how much acid that is being used. Let's suppose the acid used up here, that is 20.3 cm cube. You got it, guys?
Yes.
Yes,
Yes,
sir.
sir.
Now I'm going to explain you in a very simple way. आप लोगों ने what you have do? You have taken a pipette, take a safety bulb. By means of that pipette, you fill 25 cm cube of sodium hydroxide in the pipette, transfer it into a titration flask, add indicator inside it, and fill the burette with the acid, and open the tap of the burette. The drops will come out as soon as the indicator changes its color, okay. So you should make the tap off and just note the reading of the acid that is being used, that how much acid is used when the indicator has changed the color. Now you should waste this solution of the titration flask. You should waste it up, just wash it up. Now keep remember, my dear student, the titration flask that should be washed. When you want to wash it, you should wash it with two things. The first thing you should use, that is the tap water, and the second thing you should use to distill water. Firstly, wash it with the tap water, this titration flask, and then wash it with the distilled water, and then again transfer 25 cm cube of the sodium hydroxide in it. Now don't add the indicator. We know that this amount of sodium hydroxide requires 20.3 cm cube of acid. We should fill this burette with acid up till the point of 0. Don't add the indicator. Now open the tap and transfer 20.3 cm cube of sulfuric acid inside it, so that we know that this amount of sodium hydroxide requires this one amount of the sulfuric acid without indicator, because indicator, if it would remain within that, it will act as an impurity, okay. So we don't want to take impurity in the salt. So that is why indicator was firstly used, so that we may come to know that how much acid is required for given amount of sodium hydroxide, okay. So that in the next experiment, without indicator, you should add the same amount of the volume sulfuric acid, okay. And now this solution contains salt and water. You should heat it up. When you heat it up, it will become concentrated. Concentrated mean ये गाढ़ा हो जाएगा. इसको ठंडा होने के लिए रखते हैं. Leave it to cool, and the crystals are formed on its surface. Just take out the crystals, उनको wash करें distilled water के साथ, and dry them in the folds of filter पेपर। इनको ओवन में ड्राई नहीं करना, पेपर्स के बीच में रख के पेपर्स को जोर से आपने दबाना है, तो वो कागज जो है, पेपर जो है, इट इज गोइंग टू एब्जॉर्ब ऑल द वाटर फ्रॉम इट। ठीक है, सो दिस इज हाउ द soluble salt of titration method could be prepared. Is it clear?
Yes,
Guys?
Yes.
Yes, sir.
sir. Yes, sir.
Yes, beta, anybody wants to ask me something? No?
सर ये जो 25 cm और 20.3 cm क्यूब है, ये फिक्स्ड वैल्यूज हैं, ये हर टाइट्रेशन
No,
के अंदर
बेटा।
यही वैल्यूज रहेंगी?
बेटा ये जो आपकी ये पिपेट की वैल्यू है 25, ये तो फिक्स है, लेकिन ये जो ब्यूरेट की वैल्यू यूज होती है, ये मैंने खुद से सपोज करके लिखी है, ये कम ज्यादा हो सकती है, लेकिन ये फिक्स होगी 25 cm क्यूब।
तो सर हमें ये कैसे पता चलेगा कि कितना एसिड डालेंगे 25 सेंटीमीटर के साथ?
हमें पता चलेगा, इंडिकेटर जैसे ही अपना कलर चेंज करेगा माय डियर, तो हमें पता चल जाएगा कि जी इतना एसिड चाहिए। जैसे ही वो कलर चेंज करे, आप टैप को बंद कर दें और वॉल्यूम नोट कर लें कि कितना यूज हुआ है।
ओके सर।
Okay, okay guys, now I'm going to write down whole of this description. Okay, so can I move to the next page?
Yes, sir.
Yes, sir.
Okay dear, so first of all you should say
सर जैसे पेपर के अंदर आता है सवाल, तो सर वो 2-3 टाइट्रेशन के रिजल्ट्स बताए होते हैं उन्होंने, तो सर वो क्या होता है?
बेटे वो और चीज है, तू उसको इसके साथ क्यों कंफ्यूज कर रहा है? ये सॉल्ट की प्रिपरेशन है, वो भी इसी तरीके से है, वो भी मैं आपको बताऊंगा यार, क्यों फिक्र कर रहे हो तुम? वो भी यही चीज है, लेकिन उसमें 2-3 टाइट्रेशन होती हैं, उसमें मोल से रिलेटेड कैलकुलेशंस आपकी होती हैं। ये सॉल्ट की प्रिपरेशन है बेटा, ठीक है? अच्छा जी, टेक 25 cm cube of metal hydroxide। मेटल हाइड्रोक्साइड लाइक सोडियम हाइड्रोक्साइड आपने ली हुई थी, तो यहाँ पे सोडियम हाइड्रोक्साइड लिख दीजिएगा, मैं वैसे ही लिख रहा हूं मेटल हाइड्रोक्साइड, आप लोग सोडियम हाइड्रोक्साइड लिखिएगा इसके लिहाज से। इन अ टाइट्रेशन फ्लास्क, the second point, that is add indicator. The next point, titrate it against acid, and the acid we are going to use up here, that is sulfuric acid, from burette till end point. End point mean where the indicator changes its color. Then repeat the above process without indicator, using same volumes of acid and metal hydroxide. Then heat the solution till it become concentrated. So in every titration question you have to use the same languages, good boys and girls.
Okay, sir.
ओके
Yes, sir.
Okay, allow to cool till crystallization.
सर टाइट्रेशन में भी क्रिस्टलाइजेशन होगी मतलब?
बेटा क्रिस्टल्स के बनने को क्रिस्टलाइजेशन कहते हैं बेटा.
ओके सर.
Allow to cool till crystallization. Wash the crystals with distilled water and dry them in the folds of filter paper. Okay guys, so this is the description. You always have to write down whenever they are going to provide you with the soluble salt which contain group 1 metal or ammonium. Okay.
Yes, sir.
Yes.
Okay guys, can I move to the, if you have taken the screenshot, can I move to the next page?
Yes, sir.
Once. Okay, sir.
Thank you. Okay beta, if you want to prepare, let's suppose ammonium chloride NH4Cl, if you want to prepare this one. Okay, so now first of all you have to think about its solubility. So this is chloride. Chloride mean halide, that most halides are soluble except for slow learner man, silver, lead, mercury. So it means ammonium chloride, that is the soluble one. Okay, now the second thing, it contains ammonium inside it. So I've told you if group 1 metal and ammonium is present, you should use the word titration. So you should use titration. Now make the equation for it. So whenever the ammonium salt is present, you always have to take the carbonate of ammonium. So you should take ammonium carbonate. So ammonium, that is NH4 plus 1, carbonate CO3 minus 2. So what would be the formula? NH4 twice CO3. Okay, and the second thing, acid you should take HCl. Okay, so now react it, HCl. So ammonium and chloride, it will form ammonium chloride. Okay, so HC and CO3, they are going to form H2CO3, which is going to form H2O plus CO2. So this is gas, this is liquid, this is the soluble salt aqueous, this is soluble aqueous, this is soluble aqueous. If you want to make the ionic equation, my dear, so you have to see that which things are solid, liquid or gas. So this is gas and this is liquid. So write both of these things up here, H2O liquid and CO2 gas, and make the ions of it, and its signs are H positive and CO3 minus 2. So H plus 1 and CO3 minus 2. So write aqueous and aqueous. So this is the ionic equation. If technically you want to make the ionic equation, make the ions of the aqueous thing, ammonium plus 1, CO3 minus 2, H plus 1, Cl minus 1, NH4 plus 1, Cl minus 1. Now cut the same ions. Cl would be cut with Cl, NH4 positive would be cut with NH4 positive. So CO3, CO3, H positive, H positive, and H2O, H2O, CO2, CO2. You got it? And what should you write in a description? The description is that you should take 25 cm cube of ammonium carbonate in a titration flask, add indicator, titrate it against the hydrochloric acid from burette till end point. Repeat the above process without indicator using same volume of ammonium carbonate and hydrochloric acid. Heat the solution till it become concentrated, allow to cool till crystals are formed. Wash the crystals with distilled water and dry them in the folds of filter paper. The same description I've told you. You got it, guys?
Yes, sir.
Yes, sir.
Okay, beta, I'm going to give you 3 salts for practice from your home. So have a look. The first salt, that is potassium chloride. The second one, that is ammonium nitrate. And the third one, that is sodium nitrate. So you have to prepare these 3 salts and write down the description. Okay, so just take a screenshot
sir?
of it. Yes, beta. Yes, my dear.
सर जब भी अमोनियम का सॉल्ट आए तो NO जो भी उसका सॉल्ट हो यानी दूसरा जो उसका कंपोनेंट होगा अमोनियम के अलावा उसका हमेशा कोई वो एसिड लेना है।
यार आप जो सोलुबल सॉल्ट की प्रेपरेशन कर रहे हो उसमें दूसरी चीज का हमेशा एसिड लेना है। आपको मैंने पहले ही बताया कि सोलुबल सॉल्ट को एसिड के जो 4 रिएक्शंस हैं उन्हीं से प्रिपेयर किया जाता है, मेटल, मेटल ऑक्साइड, मेटल हाइड्रोक्साइड और मेटल कार्बोनेट।
ओके सर। सर जो अमोनियम है उस वो सर
जी
उसका
जी
कार्बोनेट के साथ हाइड्रोक्साइड भी ले सकते हैं?
बिल्कुल ले सकते हैं सर, बिल्कुल ले सकते हैं।
सर
यस आदिया जी।
कल टेस्ट है?
जी बिल्कुल कल टेस्ट है। ये इनसॉल्युबल और सॉल्युबल सॉल्ट्स वगैरह ये चीजें जो हमने की हैं इन्हीं का टेस्ट है।
ठीक है सर।
ऑनलाइन दे सकते हैं सर?
सॉरी, बिल्कुल सर, ऑनलाइन क्यों नहीं दे सकते, बिल्कुल दें।
ओके सर।